Hello, good day viewers. If you could remember, I have shown you two different ways to integrate this function x divided by x squared minus 4 with respect to x. We have used u substitution as well as partial fractions. So in this tutorial, I'm going to show you how to integrate the same function using trigonometric substitution. All right, let's get started. I would like to let x be equal to 2 secant theta, right? Therefore, we are going to differentiate both sides. The left hand side becomes the x. The right hand side, 2 is constant. If you differentiate secant theta, you have secant theta tangent theta. So now let us back substitute. From here we have, to the top we have x, which is the same thing as 2 secant theta. So we have the integral of 2 secant theta to the top. To the bottom we have x squared, and if you square x, which is the same thing as 2 secant theta, you're going to obtain 4 secant squared theta. So we have 4 secant squared theta instead of x squared, then minus 4. Then remember we have dx. Dx is now 2 secant theta tangent theta. So we multiply by 2 secant theta tangent theta. All right, let's further simplify. If we take the whole of this and multiply together, 2 times 2 will give us 4. Secant theta times secant theta is secant squared theta. Then we have tangent theta d theta, right? Remember we have d theta here. All right, then we divide by 4 secant squared theta minus 4. 4 is common, so we factor it out. We have secant squared theta minus 1. Remember we are integrating this function. From here you can clearly see that 4 will cancel 4. And from one of the trigonometric identities, secant squared theta minus 1 is the same thing as tangent squared theta. So to the top we have secant squared theta tangent theta d theta. To the bottom we have tangent squared theta. So by cancellation, you can see that tangent theta will cancel one of the tangent theta here, because we have tangent theta times tangent theta to the bottom. So all we have is secant squared theta divided by tangent theta. So we have secant squared theta divided by tangent theta, right, is what we have to integrate with respect to theta. I remember that secant is a reciprocal of cosine, so we can write it as 1 divided by cosine squared theta, and tangent can be written as what? Sine divided by cosine. So we have divide by sine theta over cos theta d theta. And we can change this to multiplication by taking reciprocal of this. So we have 1 divided by cosine squared theta multiplied by cos theta divided by sine theta with respect to theta. Gradually we are simplifying. We have not started integrating yet. So from here, cosine will divide cosine squared theta one time. So what do we have? We have 1 over cos theta sine theta. 1 over cos theta sine theta with respect to theta. I remember one identity for sine, double angle. Sine 2 theta is the same thing as 2 sine theta cos theta, right? If you can remember this. The only difference between this is this factor of 2. So for compensation, we can multiply this by 2 and multiply this by 2. It is equivalent, right? So we have something like, you can bring out 2 outside since it is constant from the top. And from the bottom, we have 1 divided by 2 cos theta sine theta is the same thing as sine 2 theta. So we have sine 2 theta d theta. I remember that 1 over sine is the same thing as cosecant. They are reciprocal, right? So this is equal to 2 multiplied by the integral of cosecant 2 theta d theta. Now it's time for us to integrate. So this is equal to our 2 is there already, which is constant, multiplied by. To integrate this, we have to first of all divide by the derivative of the inner function, which is 2 theta. If you differentiate 2 theta, you're going to obtain 2. So 1 over 2. Multiplied by what? If you integrate this, you have negative the natural log of the absolute value of cosecant theta, 2 theta, plus cotangent 2 theta, then plus the constant of integration. So this is what we have. So from here, 2 will cancel 2, so we have only this. But let us simplify this before we back substitute it. Let's simplify cosecant 2 theta plus cotangent 2 theta. Remember that cosecant is a reciprocal of sine. So let me draw an arrow here. Cosecant is 1 over sine 2 theta. Then plus cotangent, remember, is what? Cosine divided by sine. We have cosine 2 theta divided by sine 2 theta. We have common denominators, so we can add the numerators 1 plus cos 2 theta divided by sine 2 theta. We have two double angles for sine and cosine. Let us start with the cosine. To the top, we have 1 plus, this is the same thing as cos squared theta minus sine squared theta. And to the bottom, we have 2 multiplied by what? Sine theta cos theta. So we can now write everything in terms of cosine to the top, because I know sine squared theta plus cosine squared theta is equal to 1, and hence sine squared theta can be expressed as 1 minus cosine squared theta. So we have 1 plus cosine squared theta minus 1 minus cosine squared theta. To the bottom, it remains the same, 2 sine theta cos theta. And if you expand this using this minus sign, we have 1 minus 1, then plus 2 cosine squared theta, because you have cosine plus cosine, making 2 of them. This minus sign will transform this to positive, remember. All right, then we divide by 2 sine theta cos theta. From here, you can see that 1 minus 1 is 0, and this 2 will cancel this 2. What do we have left? We have cosine here. It will go into this one exactly 1 time. All we have is cosine theta divided by sine theta, the whole of this. The whole of this is cosine theta divided by sine theta. And remember that the whole of this expression is the same thing as what? Cosecant 2 theta plus cotangent 2 theta. Cosecant 2 theta plus cotangent 2 theta is what we have here. Therefore, we can substitute it back. Instead of this negative natural log of the absolute value of the whole of this, we can replace it with what we have just obtained. Therefore, we have our integration to be negative natural log of the absolute value of cos theta divided by sine theta plus the constant of integration. And if you want to get rid of this negative sign, you can take the reciprocal of this, right? So we have natural log of the absolute value of sine theta divided by cos theta plus c. And sine theta divided by cos theta is nothing but tangent theta. This is tangent theta plus c. And lastly, we want to find tangent theta in terms of x. Remember what we have started with? We have let x to be equal to 2 secant theta. So let's take this. So remember, this is what we have. Can we make secant theta the subject? Yes. Secant theta is nothing but x divided by 2 if you divide both sides by 2. I remember that secant is just the reciprocal of cosine. So we have 1 over cos theta equals x divided by 2. And cosine theta, if you take reciprocal of both sides, you have 2 over x. So now let us form a right angle triangle here. So this is our theta. This is 90 degrees. Cosine is what? Adjacent divided by hypotenuse. This is adjacent, this is hypotenuse. What will be the opposite? It will be the square root of hypotenuse squared, that is x squared, minus adjacent squared. 2 squared is 4. So we can use this to find tangent theta. Therefore, tangent theta will be what? Opposite divided by the adjacent. So the opposite is square root of x squared minus 4. The adjacent is 2. So instead of tangent theta, we can now replace it with this one, and we're good to go. Therefore, instead of this, we have natural log of this. Remember what we have started with is x divided by x squared minus 4 is now equal to the natural log of this, square root of x squared minus 4 divided by 2 plus the constant of integration, and we are done. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.